Hi, in this video we're going to look at answering question 2 of the Core 2 Practice Paper 1. I've made this paper for AQA but it's suitable for the exam boards too, and as ever if you want more information you can follow me on Twitter at Mr_G_Walter or our school account at Tupton Maths. So in this question it's asking us to look at this cross section of a metal cutter for making biscuits. Here it is, ABC. It tells us it's got straight sides, AB and AC, of 6 centimetres long, and the angle BAC is 1.2 radians. At this point, I'd be making sure my calculator's in radians before we do anything else, just in case that's useful to us later. Okay, the curved portion BC is an arc of a circle with centre A. Okay. So, first of all, it's asking us to find the perimeter of the cross-section of the cutter. Okay, so the perimeter is this plus whatever this curved part here is as well. So the curved part, we say the length of that is r theta, where theta is in radians and r is the radius. So this length here, BC, equals 6 multiplied by 1.2, which is going to give us 7.2 centimetres. So BC is 7.2 centimetres. We've also got to remember that that's just BC. We've been asked for the perimeter. So let's make sure we continue to say that the perimeter is equal to 6 plus 6 plus 7.2, which is 19.2 centimetres. Okay. Now, similarly, we've been asked for part B to find the area of the cross-section, and the area, we can say, so this is part B, the area is given by a half r squared theta. So we can simply put our numbers in. We've got a half multiplied by 6 squared, so 36, multiplied by 1.2, which is 18 times 1.2, which gives me 21.6 centimetres squared. So the first two parts, A and B, are fairly straightforward questions where we're looking at arc length and area. Let's look at part C. Part C now starts to look at this in terms of a little bit more of a functional thing. We were told these are biscuit cutters. A pair of these are going to be kept together in a rectangular box with length A and width B. Now we're going to have to see if we can work out what these values of A and B are. Let's have a little look at the diagram first before we do anything else. We can see that we've got two of these cutters. We can see we've got a length of 6 centimetres shown here, and we also know that this length along here is 6 centimetres, because it's also a radius of this first cutter, of the circle. And the same up here, we know that this bit is also 6 centimetres. The bit that we don't know is this part, and we don't know the height. So what I'm going to suggest that we do is that we draw ourselves a line going straight down like this. A right angle, at right angles. Now, again, we don't know what distance. We know it's 6 all the way across, but we don't know where this comes down to here. It looks like it might be about 3 centimetres, but we don't know that for a fact, so we can't use 3 centimetres here in case it's not, even though you might be tempted to. Please don't do that. Okay, so we've got ourselves a little right angled triangle. Let's draw it out again so we can see it in a bit more detail. It's got a hypotenuse of 6 and it's got an interior angle here of 1.2 radians. Okay, now if we're interested in the height, it's also B. So the height of this triangle up here is also B. So we could do that using normal SOHCAHTOA type trig. So we've got opposite and hypotenuse. So we can say that sine of 1.2 equals B, the height, over 6. Okay, so we can work out the height by doing 6 sine 1.2. We can do that on our calculators, remembering our calculators at this point must be in radians. So let's do that. And you will get 5.592 and some other bits. Now, the question asks us to do this to 3 significant figures. So at this point, I'm going to leave mine to 4 significant figures, just to allow for rounding. Okay, so we've calculated that B, the height B, is 5.59 centimetres to 3 significant figures. Now then, what do we know about A? Let's look. Well, A, from my little picture here, is 6 plus whatever this bit here is. So the bit that I'm highlighting with the red arrow, if I know what that distance is, or in fact this distance down here, I could add that onto 6 and work out the total of A. Okay, now how are we going to work out this distance here? Well, this distance is 6 from here minus this bit. Okay, so let's see if we can just label these parts up. What I'm interested in, I'll call it X, is this distance across here. I can work that bit out by doing the whole of this, which is 6. So 6 minus this part here, which I'm going to call Y, is going to tell me what X is. Okay, so what I'm interested in is this little bit on my right angle triangle here, Y. Okay, let's see if we can work that out then. Well, before we did sine, because it was opposite over hypotenuse. Now I've got the adjacent over hypotenuse, so I'm going to do cos 1.2 is Y over 6. So 6 cos 1.2 is going to give me a value, and again, I should already be in radians, but I'm just checking. Yeah, so 2.174 to 3 significant figures. To 3 decimal places, or 4 significant figures here. Now that's told me that this distance here, the bit I'm coloring in blue, is 2.174. I want to know the red bit, X. So I need to do 6 minus 2.174, which is going to give me 3.826. And what's that I found? Right, that's now this red part, X, which if I now add that to the 6 centimetres that I've got up here, then I can work out A. So A is now going to be 6 plus 3.826, which is 9.826, or to 3 significant figures, A will be 9.83 centimetres. Okay, that's quite a tricky question. I think spotting some of these things is not always easy, but keeping a clear mind about what it is that you're trying to do and don't assume anything too soon would also be useful. It would have been quite an easy assumption to make that this distance across here was going to be 3, and that would have been incorrect. Okay, as we've just seen. As ever, when you're doing these revision card notes, make sure that you're drawing yourselves a few pictures, get them drawn in. There's 2 formula that you need for this, and this is all about these sorts of shapes here. You need to be able to work out the arc length. So L is r theta, this is theta, and the area is a half r squared theta, where theta is in radians. Okay. If you're doing any further calculations, make sure your calculator's in radians, and also check to see if it's talking about perimeter or arc length, like this question was here. Again, it would have been very easy to do some work, calculate the arc length here, and forget that it was asking for the entire perimeter of the shape. Okay, need any help, get in touch. Otherwise, good luck, and I'll speak to you again soon in the next questions. Bye.